we have a group of 9 children which has 2 pairs of identical twins AB and CD. So, AB are identical and CD are identical. In how many ways can the 9 children be seated in a row so that A and B do not sit next to each other and C and D do not sit next to each other? Now, to solve this, we need to start off with what is the total number of combinations possible, out of which we eliminate the cases where these guys sit together. Now, what is the total number of combinations possible? Because there are 9 people, the total number of possibilities arrangements will be 9 factorial, out of which we need to now start eliminating the cases where these people are together. Now, these people can be together in 3 ways: AB sitting together, CD sitting together, or ABCD sitting together. Now, if AB are sitting together, now we know that when there is one group which is identical, if we treat the identical cases to be one item, then we have 7 items who are different from each other, and these 2 being considered as one item. So, that is 8 items in total. They can be arranged in 8 factorial ways, and these 2 people, because we are treating them as one item, they can sit either as AB or BA. So, that will give us 2 options. A total of 8 factorial into 2 will be the number of ways in which AB can sit together. Similarly, if you look at CD, now CD also can be treated the same way. So, there are another 8 factorial into 2 ways in which CD can sit together, AB can sit together in 8 factorial 2 ways, similarly CD. And now we need to look at the case where AB and CD sit together. Now, if AB and CD sit together, how many ways can we arrange them? Now, if we take these 4 people out, then we have 5 people left, and if we consider each of these sets as AB as one set and CD as one set, we have 7 people in total. So, they will be arranged in 7 factorial ways. Now, within which AB can sit in 2 positions, AB or BA, wherever they are sitting among those 4. Similarly, CD can sit in 2 positions in 2 ways, CD or DC. So, 7 factorial into 2 into 2. So, these are the ways into which we can look at using which we can look at answering this question. 9 factorial is the total number of ways in which these people can be arranged. AB sitting together, CD sitting together, AB and CD sitting together. But we need to understand that in this case is covered here, AB and CD sitting together, because AB sitting together is a case here which we have already considered here. CD sitting together is a case here which is also being again considered here, which means whatever we are subtracting, we need to subtract these 2 and add these, otherwise it will be double counting. We will be taking AB again here and CD again here. So, we need to add those cases. So, that will give us, if we take 7 factorial out, we need to take 7 factorial out as common for 2 reasons. One, if you look at the answers are in terms of 7 factorial or 8 factorial, but because the least multiple here is 7 factorial, we take 7 factorial out. So, we get a 9 into 8, 72 minus 2 into, we take 7 factorial out, we get 7, we get 8 minus 2 into 8 plus, we are taking 7 factorial out, we get a plus 4 here. So, 72 minus this is 32 plus 4, 72 minus 28, which is 44 into 7 factorial will be the answer for this question.